Hey everybody, Mr. Fortin here. Happy Monday, about 3:20 p.m. for me. I'm filming this video because we had the fire drill third block. And so we never got to debrief, what a median is. And there's actually a formula for medians actually pretty close to it appears in actually the formula for area of a trapezoid. Okay, so we'll get to that in a second, whenever that was second block. Also mid-segment, right? If I know the length of the mid-segment, well, then I know the length of this third side, right? They're kind of related. Anyways, I'll kind of talk about it real quick. And on your homework tonight, you're going to have some crazier diagrams kind of like this. When you have something like this going on here, you're going to have to bring it all together and solve it. So I asked a question, block 2, gave a few seconds. It's hard for them to piece together, right? When you have a diagram like this, and you're going to have to know how to work with this diagram here to do this question down below, questions 12 through 16. So I'm hoping to go through that here. Okay. Thank you for watching this. Okay, medians came up in the group work, which you didn't have a lot of time, block 3 today. I think I only checkpointed like 1 or 2 groups, and then the freaking fire alarm went off. Anyways, medians here, remember a median, how many medians are there in a trapezoid? Just one, because medians always connect the legs. They connect the legs of your trapezoid. That's how the median is defined. It's the segment that connects the 2 midpoints of the legs. And so when you have that there's some neat geometric things that happen. First of all, as you know, okay, it appears parallel to this side, parallel to that. It is parallel to that, okay? And this won't be, we're not going to go through proof of why the thing that connects the midpoints is parallel to the other 2 sides here, and those are the bases, okay? The 2 parallel bases. I have a third parallel line now because I'm median. We're not going to go through the proof of that because it's proven for you in chapter 11. Coordinate geometry. We're not even gonna have time to do chapter 11 this year, okay? So anyways, it's a theorem, it's a thing, right? We're gonna work with it now. Let's not worry about the proof. Anyways, it's parallel, so that's why I added this little tick mark here. And it's also, if we notice it here, it's smaller than this base, larger than this. Sorry, it's larger than this base. Look, it's bigger than that base. This median is bigger than that base, and this median is also smaller than that base. And it's actually, the average of the 2, okay? It's the half of the sum of the lengths of the bases, okay? So half the sum. Remember, sum, I have to add the lengths together, this length plus this length, and half of that would be divide by 2, okay? So it's just like calculating an average. When I average 2 numbers, I add this, and I add this number together, and I divide by 2, I get an average, I get the length of the median, okay? So the question I asked second block about this was, can somebody tell me a bit of a formula here to keep in mind, the length of a median, okay, median length. And I can put here, I'll put length because I'm talking the length of that median. So the length of the median, because the length of a median actually appears in the area of a trapezoid formula. That's right, area trapezoid formula. And I know many of you have done areas in the past, and in Algebra 1, actually, oddly enough, when I start Algebra 1, there's like a trapezoid in the very first problem that I give a lot of time. And a lot of people have to work with one another. They arrive there. They get to the area of a trapezoid formula. A lot of people have worked with it before, okay? But anyways, length of the median, okay, my median here, I take this, I add this, and what do? I divide by 2, okay? So I'm asking people who've done this before, have done area of a trapezoid formula before, about what we could perhaps label this as if we're going to come up with a formula. Okay, well, I can make this x and I can make that y. Then it would just be x plus y over 2. But that's not that interesting to me. That's not that interesting to me. I want to get to the area formula, okay? Because an area formula, they call this base something, they call it this. They call it B1, base 1. Okay, and they call this here base 2. That appears in the area of a trapezoid formula, B1 and B2. And how does it appear in the area of trapezoid formula? Well, it's B1 plus B2 divided by 2. Okay, so to get the length of the median, I simply add the 2 lengths of the bases and divide by 2. It's average. That's the average length of the bases. Okay, that's what the median is. And you know what? This is it. This actually appears in the area of a trapezoid formula. To get the area of a trapezoid, I'd simply need to find the length of the median and multiply the height, the perpendicular length that would run the distance between the parallel lines are. Anyways, we'll get to the area formula of a trapezoid in chapter 10. No, sorry, chapter 9. I think it's chapter 9 here, but this appears in it. Anyways, length of median, so I add them together and divide by 2. Okay, and that's what we'll be doing. Y'all have more problems on it. Okay, mid-segment, a little bit easier here. Mid-segment, hey, any triangle, trying to draw a triangle, boom. Here. Draw a triangle, it's got 3 sides, so it's got 3 medians. Yeah, it's got three mid segments because I got a mid segment here. Okay, this also can go to a midpoint. Boom, 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 boom. And this can connect midpoints too. So I actually connect, there are three mid segments, a mid segment here, a mid segment here, and a mid segment here. And you know what? Actually, there's question number 4 in your classwork today. This creates 4 congruent triangles, actually, just by connecting midpoints. Pretty neat. 4 congruent triangles, and they are actually all similar to the original triangle. We have talked about similarity. That'll be in chapter 5. Okay, but anyways, because the deal with the mid segment is, right, you're given the theorem, we're not going to prove it until later, that, you know, if my mid segment here is x, it's half as much as the side. This is called the third side that it doesn't intersect. So this length here would have to be 2x. Have to be 2x. This is half of the length here, okay? So if this is 5, this is 10. If this is 5, this is 10. And why does that make sense? Well, you know what? This mid segment here is, well, it's the same length as this. It's the same length as this. All 4 of these triangles are congruent. That can help you keep and remember that, you know what, this side here is half the length of this side here. Well, why? Well, it's the same thing as this. Look, this actually, if I drew this accurately, this would more look like a parallelogram. It'd be a parallelogram right there. Also a parallelogram right here. This looks more like a parallelogram here if I'm eyeballing it, okay? And you know what? This would be half the length of this side, okay? So a mid-segment is half the length of the side that it does not intersect, okay? Remember, a triangle, unless it's an isosceles triangle, a triangle doesn't have bases. They just have 3 sides. So a mid-segment connects 2 of the midpoints, and then the third side it doesn't intersect, well, it's half as long as that. And it's also parallel to this third side. This side here, parallel to that side, if I drew it accurately, okay? But the idea is, you know, this side here, it's half the length. So you know what? I can put a tick mark there. Look, 1, 1. It's congruent to that. It's congruent to that. Half the length of that side here, okay? This mid segment half the length of this side here. Let's look at this. This was given to us on the classwork in second block. I didn't get a chance to ask him a third block about this, but I gave him a problem here. Let's look at this diagram right here. This is what I'm going to do. Check it out. I'm going to make this x. I'm going to make this 30. Okay, I'm going to make this 90 right here, and I'm going to make this y. Pause for a second. Try to figure out what does x equal. What does y equal? Ready, set, go. Are you unpaused? Okay, good. You're unpaused. I'm not paused and try to figure it out here. All right, let's check this out. Let's try to figure out what's going on here. So anyways, I probably should have given you more info here. I should have said that, you know, maybe these are parallel or something. You kind of need parallel sides, okay? Because, ooh, I got a trapezoid here. Look, there's a trapezoid. One thing I want to point out here too, with the mid segment here in the middle, ooh, a mid segment actually creates a trapezoid down below it. So I have trapezoid in this problem here by just introducing a mid segment, because mid segment's parallel to the third side, okay? Here I have a trapezoid down here. I have a trapezoid up top. I have a whole trapezoid here. So trapezoids galore when it comes to mid-segments and medians, okay? So if we look at this diagram, where to begin, okay? Check it out. I have a triangle up here. Look, I have another, look, this triangle right here. And if I look at it, this length here, this segment length x is a mid-segment. Yes, it's a mid-segment. It's going to hit the midpoints of that side and that side of this sort of top triangle right here. Okay, so what is x then? What does x equal? Okay, x equals 15. Okay, x is 15 right there. 15, 30. Oh, what's y? What's y then? Okay, wait. Well, there's a few different ways I can figure out y at this point. Okay, one, I can use this. This is 15. You know what? Actually, I got myself a freaking trapezoid here. Oh, right there. Ah, boom, 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 boom. Okay, so 30 is my median. 15 is one of my bases. My other base, well, okay, so I can set up an equation. I can set up 30 equals 15 plus y divided by 2. Get my answer. Okay, right? 15 plus y divided by 2. 30 is the average of the two bases. We just don't know what this is, okay? What might be easier here on this one here is to actually keep this. Okay, notice this here. I got this trapezoid here, and y is a median of that. Okay, so this is probably the easier trapezoid to deal with on this one here, okay? The median, which is length y, is equal to half the sum of the length of its bases, okay? Top base, bottom base, little base, big base, it's somewhere in between that because it's half the sum of two, okay? 30 plus 90 divided by 2. Okay, and that's going to equal 30 plus 90 is 120 divided by 2 is 60. And if we notice this here, what's going to happen in this problem is going to happen on this problem here too as well. It kind of goes in order, 15, 30, 60, 90. Look, it's adding my 15 each time, okay? Let's look at this one now. We're going to do 12 through 16, which is on your homework tonight, and we'll kind of take a look at it here for a second. Remember, this here, AD, is a mid-segment. This is a mid-segment of what? Of triangle TBE. Cool. Okay. And then, hey, you know, I got other things going on. I don't know if it's gonna be that useful here. BE, for instance, is a median. This right here is a median of the purple trapezoid that we have here. Okay, so if we're reading the problem here in exercises 12 through 16, TA equals AB. Okay, so A is the midpoint of segment BT. And also too, AC, B is the midpoint of segment AC, which is a leg of this trapezoid. Okay, they never give it to you that it's a trapezoid, but I think we should assume it's a trapezoid. They really should say these are parallel. Actually, we know this is parallel to this. I don't know how you prove B is parallel to CE. Okay, so maybe there's an oversight. Probably should have given you BE and CF. Sorry, CF are parallel. Okay, TD is the same thing here too. So D is a midpoint there, he's a midpoint there. All right, so compare lengths AD and BE. Okay, so here AD is half the length of BE. Okay, so I could write this. I could write AD equals 1/2 BE. Okay, and I could do that, right? I could also say that, you know, that 2AD, if I double it, I would get the length of BE. So that's kind of all it's looking for in that problem here. Okay, compare the lengths of AD, BE, and CF. Okay, AD, so think of trapezoid CFDA. Well, I know that BE is the median of that trapezoid CFDA. So I know that BE is equal to AD plus CF. Plus CF divided by 2, okay? Because it's the average of AD and CF, half the length of the sum of the bases, okay? So I have that, and we're good to go, okay? AD equals 7, BE is gonna equal 14, right? This here, remember BE, the median of the trapezoid, it's also the third side of this triangle, of which AD is mid-segment. Whew, lots of stuff going on in math and geometry, okay? It's hard to keep track of it all. Rewatch this video as many times as you need to kind of get it. CF, okay? If we figure out CF, I think it's a little bit more work here because CF is this longer side here. I could set it up, I could figure it out, but I could also, I could follow this pattern that we have here. Yeah, okay? So anyways, but I might as well do it with using the median formula because CF is one of the bases of the trapezoid. Okay, BE is my median, so that's going to be over here. Remember, the median is half the length of the sum of the bases. And my base here is AD, so that's 7. And then I'm going to add CF to it and get my answer, okay? So when I have it in this situation, what I could do to both sides is multiply both sides by 2. Check it out. Multiply both sides by 2. 14 times 2 is 28. Okay, 7 plus CF divided by 2. Well, the opposite of dividing by 2 is multiplying by 2. So dividing by 2 and multiplying by 2 cancel each other out. Okay, so whenever this happens, you can just drop the 2 because you doubled this side. I'm doubling this side by getting rid of the dividing by half. Hopefully that makes sense. And my answer here is 21. Okay, so check it out here. 7, 14, 21. We're adding by 7 each time. We're adding by 7 each time, okay? We're basically doubling this, and then we're tripling this, okay? Tripling this, okay? If BE equals 26, then AD equals 13, okay? CF would equal, well, this here, AD is X, BE is 2X, CF would actually be 3X, okay? Why? Well, 2X is it's halfway in between X and 2X, okay? So this is actually gonna be 39. Okay, and last one here, numerical answers here. AD equals X, BE, well, it's twice as much. Okay, so here, right, twice the length of AD. This goes back to the very first problem here. 2AD would equal BE, right? Because AD is the mid-segment of this green triangle that we have on top here, triangle TBE. Okay, so 2 times AD equals BE. And so they're giving us an expression for AD, which is X. So I'll replace AD with X. And twice it would equal the expression they give us for B, which is X plus 6. Okay, so I go ahead and solve this one. I'm going to get that X is equal to 6 once I solve that. And CF would be, if AD is X, so it would be 3 times that, so it would be 18. There you go. Fun times in the math. Hopefully you get it. Message me if you have any questions. Thanks for watching. Thank you for working hard and living with these fire drills and whatnot here. All right. Message me if you have any questions. Take care.